The power leap. From 707 to 777. Did you know that a single engine on a Boeing 777 produces more thrust than all four engines of a Boeing 707 combined? This incredible leap in power is just one example of how far jet engine technology has come. In this video, we'll explore the evolution of jet engines and the engineering marvels that make modern air travel possible. The journey of jet engines began in the 1930s with the invention of the turbojet. Since then, engineers have been pushing the boundaries of what's possible in aviation. We've seen advancements in materials, design, and efficiency that have transformed air travel as we know it. From the early days of the Boeing 707 to the modern marvels, like the 777, jet engines have undergone a remarkable transformation. These technological leaps have not only increased power and efficiency, but also improved safety and reduced environmental impact. Are you ready to discover the engineering feats behind this incredible evolution? Let's get started on our journey through the history of jet propulsion. As we journey through the evolution of jet propulsion, let's take a closer look at what makes modern jet engines so powerful. What exactly is going on inside these engineering marvels that allows them to generate such incredible thrust? The answer lies in a carefully orchestrated dance of components, each playing a crucial role in the engine's performance. At the heart of every modern jet engine are 5 key components: the inlet, compressor, combustion chamber, turbine, and exhaust nozzle. Each of these parts works in harmony to transform air and fuel into the massive thrust that propels aircraft through the sky. The journey begins at the inlet, where air is drawn into the engine. This seemingly simple step is actually a feat of engineering, designed to slow the incoming air and prepare it for compression. As we move deeper into the engine, we encounter the compressor. Here, the air is squeezed to incredibly high pressures, increasing its temperature and setting the stage for efficient combustion. Next, we reach the combustion chamber, where the magic happens. Fuel is injected into the compressed air and ignited, creating a powerful explosion. But how does this explosion translate into forward motion? That's where the turbine comes in. The hot, high-pressure gases from the combustion chamber rush through the turbine blades, causing them to spin at incredible speeds. This spinning motion serves 2 purposes. First, it drives the compressor, creating a self-sustaining cycle. Second, in some engines, it powers a large fan at the front of the engine, which provides most of the thrust in modern turbofan designs. Finally, the exhaust nozzle directs the remaining hot gases backwards, providing additional thrust. But how does this modern marvel compare to its predecessors? The engines of the Boeing 707, for example, were much simpler in design. They lacked the large fans seen in modern turbofans, and their compressors were less efficient. This meant they burned more fuel and produced less thrust, explaining why 4 707 engines produced less power than a single modern 777 engine. The leap in performance we see today is the result of decades of refinement. Engineers have improved each component, using advanced materials to withstand higher temperatures and pressures, and fine-tuning designs for maximum efficiency. The result is an engine that's not only more powerful, but also quieter and more fuel-efficient than its predecessors. As we've seen, the modern jet engine is a testament to human ingenuity, pushing the boundaries of what's possible in aviation. But this is just the beginning of our journey. There's still so much more to explore about these incredible machines. What materials make these high-performance engines possible? And what challenges did engineers face in creating them? Stay with us as we continue our exploration of jet engine technology. As we've seen, the modern jet engine is a marvel of engineering. But have you ever wondered what makes these powerful machines possible? The answer lies in the materials used to construct them. These unsung heroes of aviation have played a crucial role in the evolution of jet engines, allowing them to achieve previously unimaginable levels of power and efficiency. Let's take a journey through the history of jet engine materials. In the early days of jet aviation, engines were primarily constructed using steel and aluminum. While these materials were strong and lightweight, they had limitations when it came to withstanding the extreme temperatures and pressures inside a jet engine. Enter the era of heat-resistant alloys. These special metals, often containing elements like nickel, cobalt, and titanium, can maintain their strength and integrity even at temperatures that would melt conventional materials. The development of these alloys was a game-changer for jet engine design, allowing engineers to push the boundaries of performance. But the innovation didn't stop there. In recent decades, we've seen the rise of composite materials in jet engine construction. These advanced materials, often made from carbon fibers embedded in a resin matrix, offer an unbeatable combination of strength and lightweight. By incorporating composites into key engine components, engineers have been able to significantly reduce the overall weight of jet engines, leading to improved fuel efficiency and performance. The impact of these material advancements on jet engine capabilities has been nothing short of revolutionary. Modern engines can operate at higher temperatures and pressures than ever before, translating directly into increased power and efficiency. For example, the high-temperature alloys used in modern combustion chambers allow for more complete fuel burning, while lightweight composite fan blades enable larger, more efficient engine designs. However, the path to implementing these advanced materials hasn't been without its challenges. Developing new alloys and composites that can withstand the extreme conditions inside a jet engine requires years of research and testing. Engineers must carefully balance factors like strength, weight, heat resistance, and cost to create materials that meet the exacting standards of the aviation industry. Moreover, integrating these new materials into existing engine designs often requires rethinking entire systems. A change in one component can have ripple effects throughout the engine, necessitating a holistic approach to material selection and implementation. Despite these challenges, the rewards of advanced materials in jet engine design have been immense. Today's engines are not only more powerful and efficient than their predecessors, but also more durable and reliable. As we look to the future of aviation, it's clear that continued innovation in material science will play a crucial role in shaping the next generation. Engineering challenges and triumphs. While advanced materials have revolutionized jet engine design, they're just one piece of the puzzle. The journey from concept to a fully functional, efficient, and safe jet engine is fraught with engineering challenges that push the boundaries of human ingenuity. Let's explore the hurdles engineers face and the triumphs they've achieved in creating these marvels of modern aviation. One of the most significant challenges in jet engine design is thermal management. Did you know that temperatures inside a jet engine can reach up to 2,000 degrees Celsius? That's hotter than the melting point of most metals. Engineers have had to develop innovative cooling systems and high-temperature materials to ensure engine components can withstand these extreme conditions. Fuel efficiency is another critical concern. With rising fuel costs and growing environmental awareness, airlines demand engines that can do more with less. This has led to the development of high-bypass turbofan engines, which use a large fan to move a greater volume of air around the engine core, improving efficiency and reducing fuel consumption. Noise reduction has been a persistent challenge in jet engine design. The roar of early jet engines was not just a nuisance, it posed real problems for communities near airports. Engineers have made significant strides in this area, developing technologies like chevron nozzles and acoustic liners to muffle engine noise. Environmental concerns have also shaped jet engine development. Modern engines are designed to minimize emissions of harmful pollutants like nitrogen oxides and particulate matter. This has required rethinking combustion chamber designs and fuel injection systems to create cleaner burning engines. But how do engineers overcome these challenges? It's a process that combines cutting-edge computer simulations, extensive testing, and often learning from failure. Virtual prototyping allows engineers to test designs before building physical models, saving time and resources. Wind tunnel tests and flight tests help refine designs under real-world conditions. Performance in extreme conditions is another crucial consideration. Jet engines must operate reliably at high altitudes where the air is thin and temperatures can plummet to -60 degrees Celsius. They must also withstand the scorching heat of desert runways and the corrosive effects of salt air in coastal regions. Engineers conduct extensive testing to ensure engines can handle these varied environments. Maintenance and reliability have seen significant improvements over the years. Modern jet engines are designed with modular components that can be easily replaced, reducing downtime for repairs. Advanced sensors and monitoring systems can detect potential issues before they become serious problems, improving safety and reducing maintenance costs. As we look to the future, new challenges await. The push for even greater efficiency and the potential for alternative fuels will drive the next generation of jet engine design. What innovations will we see in the coming decades? The sky's the limit for these engineering marvels. As we've seen, jet engine technology has come a long way since the days of the Boeing 707. But what does the future hold for these marvels of engineering? Imagine boarding a plane powered by electricity, or flying at hypersonic speeds. These concepts might sound like science fiction, but they're closer to reality than you might think. The next frontier in aviation is all about pushing the boundaries of what's possible, with a focus on sustainability and speed. Electric and hybrid propulsion systems are gaining traction, promising quieter, cleaner flights. Meanwhile, researchers are developing hypersonic engines that could revolutionize long-distance travel. And let's not forget about sustainable aviation fuels, which could dramatically reduce the environmental impact of flying. As we look to the skies of tomorrow, it's clear that the evolution of jet engines will continue to shape the future of air travel in exciting and unexpected ways.